Section 1.4 deals with complex numbers. So here are our objectives for the day. Add and subtract complex numbers, multiply complex numbers, divide complex numbers, and then perform operations with square roots of negative numbers. Okay? So let's remember a couple things. A complex number usually takes the form of a plus bi. That's our complex number. Okay? Do you remember why it's called a complex number? It's complex. There's two parts. There's this part and then there's this part. The first part is called the real part. And the second part is called the imaginary part. Okay? Something else I want you to remember is where imaginary numbers come from. Okay? What is the square root of -1? Well, normally we would think what times itself equals -1, and we realize nothing times itself would be -1, so that is where the I comes in. Okay? So one thing I want you to realize is that A plus BI is going to equal C plus DI if and only if. You ever heard that before? If and only if? Sometimes it's abbreviated like this. If and only if. IFF. Okay? When are these two going to equal each other? What has to be very true about this? What does A have to equal? C, right? The real part has to equal the real part. What about B? What does B have to equal? B has to equal D. So this statement is going to be true if and only if A equals C and B equals D. Okay? Which also means if A equals C and B equals D, then we know this is true. Okay? Any questions about that? Alright, so that's just a general overview real quick about complex numbers. So we're back to our objectives. Our first one is to add and subtract complex numbers. Right? So let me make sure you can do that. So 2 plus 3i plus 4 plus 5i. So quite obviously this is adding complex numbers, right? Well, when we're adding complex numbers, what parts do we add? The real parts, so 2 plus 4. And then we add the imaginary parts, right? 3i and 5i. 8i. Done. What if we have 2 plus 3i minus 4 plus 5i? Again, just real and just imaginary, right? When's the only time that combining real and imaginary ever worked? Space Jam. It's the only time. Space Jam is the only time that combining real and imaginary worked. Some people say Who Framed Roger Rabbit, maybe. Okay? Otherwise, we can only add real parts or subtract, in this case, 2 minus 4, which is -2, and we can only subtract imaginary parts, 3i minus 5i, -2i. Everybody okay with that? Okay. The hardest part, sometimes people right here would put 8i because of 3i and 5i. What did they forget? We're subtracting. Okay, so don't forget that. Sometimes we even go so far as to pretend that's a -1 and distribute it to each one of the terms to remember that that's what's happening. Does that make sense? Okay. The next one of our objectives is to be able to multiply complex numbers. Okay. Yes, I need you to be able to multiply a complex number times a complex number, but I also need you to be able to multiply a scalar by a complex number. For instance, 2 times 3 minus 4i. I'm not allowed to add or subtract complex numbers, or excuse me, real and imaginary parts, but can I multiply? Can I say 2 times 3? Well, that's pretty easy. That's 6. Those are both real numbers. It's not a big deal. Am I allowed to say 2 times negative 4i? What do you think? Let me ask you this question. Is this problem right here the same thing as this problem right here? Multiplying something by 2 is just like adding it twice, right? So wouldn't I get 6 minus 8i over here? So do you think I'm allowed to multiply real and imaginary? Yes. Any questions about that? Okay. So yes, now for sure I do need you to be able to multiply a whole complex number by another complex number, like this. Okay? So what are we going to think of when we do this? We're just going to multiply real parts and multiply imaginary parts and be done? Nah. We got to distribute, don't we? That and that. What is 3 times 5? 15. What's 3 times 6i? 18i. And then I have to do 4i, which is my childhood nickname, times 6i. What's 4i times 5? 20i. And what's 4i times 6i? 24i squared. So now I can combine my like terms, right? For sure combine those. Something else is going on here. Do you remember what it is? I squared. I told you at the beginning the square root of negative 1 is I, right? Well, what if I square both sides to get the value for I squared? What's the value for I squared? Negative 1. Okay? So I don't want to leave this I squared in the problem because I know the value of that is negative 1. So then I have negative 1 times 24, which gives me negative 24, right? Well, what's negative 24 and positive 15? So I've got this 15 and I've got this negative 24 now. Negative 9. And then I have 18i and 20i. 38i. So far we've done adding and subtracting and multiplying complex numbers. Okay? Before we go on to dividing, I just want to make sure that you understand that some of you are a little panicked right now because of complex numbers. I do want to make sure you understand that we have a friend. Okay? First of all, we need to look at our settings on our calculator, our document settings, and we need to make sure that real or complex is in rectangular mode, not real mode. And then we want to make that as our default for now because that's what we're working on. We'll eventually want to change that back to real when we're not working with complex numbers anymore. Do I need to go through that again real quick? Okay. So we're on just on this home menu, go to settings, go to document settings, which is number 2, and make sure where it says real or complex, make sure that says rectangular. Okay? Because when it does, and I make a new document, and no, I don't want to save my old, what is it doing? No, I don't want to save my old. And I create a calculator document, I can look at this problem where it says 2 plus 3i. Now, do I use this I right here? The letter I right here? Are we talking about the letter I? No, we're talking about imaginary. Do you know where imaginary I is? It's an actual button. It's not an imaginary button. Okay? The pi button, which is right down here. When I press the pi button, it's the second one over. That's the I that I need. Plus, we're doing that first one we just did, 4 plus 5I. Oh look, 6 plus 8I. That's exactly what we got. Do we need to check the subtraction one, or are you okay with that one? Okay, then let's check the multiplication one, the one that we just did. 3 plus 4I times 5 plus 6I. Negative 9 plus 38I. What a coincidence. Now, do I always want you to use the calculator? I don't. I want you to know how to do it, which is why I showed you how to do it first by hand, right? But do I want you to get bogged down in the arithmetic so that we can't do anything else? No, absolutely not, which is why I show you how to do it in the calculator. Okay? So are you allowed to do these on the calculator when you get to your homework problems? Yes. Okay? I'm not going to make you do these by hand. You know how to do them. If I said to you, you have to do this one by hand, you'd say, okay. Because you understand this. You know this. Okay? I'm letting you use the calculator for this because we don't want to get bogged down in the technical stuff, in the arithmetic stuff. We want to get to why in the world do we even use complex numbers. Okay? Got it? Okay. We also have, as part of our objectives, divide complex numbers. Okay? Most of these problems are going to look something like this. 3I over 4 plus I. That's what it's going to look like. Okay? Now it looks like, when you first look at it, it really looks like there's nothing you can do, doesn't it? Except for the fact that we can't have complex numbers in the denominator. Okay? The imaginary math police do not like that. So what we have to do is get that out of the denominator, and here's what we do. We got to know the complex conjugate. It's a really long word for a really easy thing to find. If this is 4 plus I, the complex conjugate is 4 minus I. If it was 7 plus 6I, the complex conjugate would be 7 minus 6I. If we started with 4 minus I, what would be the complex conjugate? 4 plus I. Okay? Real part stays exactly what it is. Imaginary part changes signs. That's all it is. That's all that is to it, finding the complex conjugate. Okay? But if I just multiply the denominator by the complex conjugate, I've completely changed the problem. So what else do I have to do? Yep. Now I'm just multiplying the number by 1, and I'm not changing its value at all. I'm just manipulating where things are. Okay? So when I multiply these together, well, the top, I distribute 3I times 4, and I get 12I. And 3I times negative 1, which gives me minus 3I squared. But I know that I squared equals negative 1, so I really have 12I plus 3, right? And we typically write 3 plus 12I. We typically write the real part first and then the imaginary part. Is it wrong the other way? No, it's just for the same reason that we write 2x plus 5. We typically write the variable first and then the constant, right? Same kind of way here, except this is we're writing the real part first and the imaginary part. Okay? Just want to be making sure very clearly, because of the fact that I just used an example with an x in it, I need to make sure that you realize that I is not a variable. We're not going to be like solving for I later on or something like that. I represents the imaginary part of the complex number. Does that make sense to you? Okay. So it's not a variable. It's not something that changes value. Okay. Now in the denominator of this fraction, we just did the numerator because we could do it real quick and get it out of the way, right? In the denominator of this fraction, I end up with 16 minus 4I plus 4I minus I squared. But again, you know that I squared equals negative 1, and negative 4I plus 4I is 0. So I end up with 16 plus 1. That's nice. So that would be the answer. Okay? Now, I don't know if you have experienced too much of this, but sometimes your the math lab program can be picky about how it wants the answers. Okay? Sometimes it'll take this as the answer. Sometimes it will not, and it wants this as the answer. Because it wants the real part separated from the imaginary part. Does that make sense? This answer is not wrong, but it is not separated real and imaginary like this one is. So if you put something like this in and it says it's wrong, maybe it's in the wrong form, what it wants is this. It wants the real part and the imaginary part separated. Okay? Does that make sense? The last part of our objectives today talks about performing operations with square roots of negative numbers. Okay? So let me give you an example of what I'm talking about. An example would be if I have the square root of negative 18 minus the square root of negative 8. Well, the thing about this is I can't do anything with those because they're not the same root. Okay? So I'm going to try to simplify these as much as possible, and then maybe I might be able to do something with them. Okay? Hopefully you remember how to simplify radicals to begin with. If you don't, I'll just give you a real quick crash course. Okay? If you don't remember, we may need to talk. Okay? When we have time to work. But this is really negative 1 times 9 times 2. And I didn't choose negative 1 times 6 times 3 because I don't know the square root of 6 or 3, but I do know the square root of 9, don't I? Okay? So tell me right now, what is the square root of negative 1? I. What's the square root of 9? 3. What's the square root of 2? I don't know either. Okay? So I've just simplified that first part of the problem. Then I have the square root of negative 8. Well, what am I going to break it down into? Negative 1, 4, and 2. Yeah, because I know the square root of 4, right? Well, what's the square root of negative 1? I. What's the square root of 4? 2. And what's the square root of 2? I don't know either. But the cool part about this is I can do something with this because now my roots are the same. This is the square root of 2, this is the square root of 2. Because those are the same, I can say 3i minus 2i is 1 root 2. Root 2 is not a variable, but I can kind of treat it like a variable. Does that make sense? And then that is my answer. Okay? Any questions about that? One other example of a problem that you might see would be something like this. Negative 1 plus the square root of negative 5 squared. Well, hopefully by now you know that this means negative 1 plus the square root of negative 5 times negative 1 plus the square root of negative 5. Yes? And you know that this also means distribute. So negative 1 times negative 1 is 1. Negative 1 times the square root of negative 5 is negative square roots of negative 5. Negative 5, square root of negative 5 times negative 1 is negative square root of negative 5. And then the square root of negative 5 times the square root of negative 5 is negative 5. Do you remember that? If I multiply two things that are being, like, it's exactly the same thing as square root of something, it's just going to be the thing that's inside. Because the property that we're working with says if I'm multiplying square roots, I just multiply what's inside and keep the square root. Well, that gives me 25, right? And I take the square root of it and I get the negative 5 because that's the number that was inside to begin with. You okay with that? Yes? Okay. Yes. So I have a negative square root of negative 5 and a negative square root of negative 5. So what does that equal? Well, how many of them are there? How many negative square roots of negative 5 do I have? I have 2, right? So I have 2 square roots of negative 5. And then I have 1 minus 5. So minus 4, right? And then if we want to get this in the right order, because sometimes it'll make you put it in the right order, we want the real part first, -4, and then we want the imaginary part. Well, do we even have an imaginary part? Well, I still have the square root of -5, right? So if we think about that, that's -1 times 5. Now I don't know the square root of 5, do I? But I know the square root of -1. So I can say it would be plus, right? But if I'm taking the square root of -1 out, oh, how can I write the right answer? Can I go back a step? Is that all right? I asked you how many of these I had, and we said 2, and I wrote down a 2 and went on, right? But don't I have -2 of them? Because this is like a -1 and a -1. Is that okay? So I have -2I root 5. Because I simplified this to be I root 5. And then I already had the 2 on the outside. Does that make sense? And that is the answer right there. Any questions? Do we need to go back over or talk about any of these objectives for today? Good? All right. Mark it, set, go.